Hello and welcome to Module 6 in our Python series. In today's session, we're going to be working with Lambda expressions. We're also going to be talking about recursion and solving some problems using recursion. And then we do 2 mini projects. And finally, I will leave you with a sneak peek into what we're going to do in the next session. So let's begin with Lambda expressions. Lambda expressions are expressions used to create anonymous functions. So far we've been using def to create functions, but today we'll be creating anonymous functions using Lambda. These expressions can have any number of parameters or arguments, but most importantly, we can have just one expression. Okay, this is the most important part. So let's get started with solving some problems using Lambda. The first one, write a function to add two numbers. And I'm going to go straight to the shell. And all we need to do is specify a variable here equal to the keyword lambda followed by the parameters going to the function or the expression. We need to add two numbers, so there will be two parameters. That will be followed by a colon, and then we need to specify what we want done with these two parameters, a plus b, and that's it. Okay, now if we look at the type of what add nums is, you will see that it's a function. Right, so Lambda creates a function object. Okay, that's important to remember as well. And now we can execute this, sending in some values. So let's say 19, 29, A and B, and then we'll get the sum. Next one, write a function to sort a tuple. Now I already have created a tuple earlier. We have T2 there. And we need to sort that. So again, sorted to equal to lambda, the parameter that's coming in, let's call it toop(x). We don't necessarily have to use the same name. Okay, then colon, and what we want done with that tuple. So we want it sorted. Remember, to sort a tuple, we need to use a sorted method. The sort method is only for lists. Okay, so sorted and T2. But we want this returned in tuple, let's say. So tuple. Now, of course, I cannot say T2 here. What should I be saying? I should be saying toop(x) because that's the name of the parameter. Okay. And that's it. And now if I pass T2 as a parameter to this lambda function, right, then I will get a sorted tuple. Right? The next one is write a function to sort a list of dictionaries based on a given key. Now again, I have a list of dictionaries here, right? But we have not really dealt with sorting a list using key or using the key parameter. So we'll do that first before we use lambda. Now to use the key, the syntax is something like this. We would say sorted in the list name, whatever the name of the list, comma, key equal to, and this would have to be a function. Okay, so this is the syntax for using the sorted method with the key. So how do we get the key? Let's say we needed to sort these dictionaries on the basis of color. We know that if we use list with a dictionary, we can extract the keys. So if I say list of and of 0, right, I will get the keys. And then I need the first element from this list. Remember, that's the 0th element. So I would say list of 0, right? And then I want 1 from that list, and I never get color. Okay, so we'll use this now and first create a function. We'll call it get key, and this is going to take every element in this list, right, and then return the key for that dictionary. So D here represents every dictionary in this list. Okay, now within that we will just say return, and we will use this, right? So return, remember here we'll have to use D, right, because D is a parameter and that is a dictionary that is coming in. So D, right, and then list of D, right, and then 1. Okay, so if you want to separate this and then put in the 1, you can do that as well. Okay, so now we are returning for each element in this list the key that would be color. Okay, now all we need to do is print out that sorted list. So sorted, and then what's the list name? Annie, comma, key equal to, what's the function name? Get key, right? And there we have it sorted. Okay, now to use Lambda, what we do is we will say sorted equal to, let me just clear the screen, right, because it's a bit crowded. We write a Lambda for that as well. We need to import OS first. So import OS and then define a Lambda function here equal to Lambda. This is going to take no parameters, and then we just say os.system and pass in CLS. Okay, and that's it. And if we call clear now, we'll clear the screen on that. Okay, so now this is our dictionary again, right? And we need to use Lambda with sorted. Of course, we need to sort on the basis of the key color. So here we'll say sorted equal to sorted, the name of the list, which is Annie, right, comma, key equal to, and now we will use Lambda. Lambda, we need to specify the parameter, that's Annie, right, and then colon, and from the list we need color. Okay, and that's all. And now if I say sorted, right, you will see that it has been sorted. Right, moving on to the next. Write a function to separate the odd numbers from a list. The result should be a list. How do we do this? Now let's say I have a list of numbers and I need to extract from those the odd numbers. Right, so what have we learned? we learned, let me say, odd equal to x or x in numbers if x %2 not equal to 0. Remember this is list comprehension. Now we need to use lambda instead. To use lambda, what we can do is we can use a filter method. The filter method again requires a function, just as we did just now for the parameter key with the sorted method. So let's define that method. I'm going to show you first without using lambda, and then we use lambda. Okay, so def find odd, and again every element in the list is going to be brought to this function, and here we will say if x %2 not equal to 0, right, then return x. And the syntax for using the filter method is like this. We will say odd nums equal to, then we need to specify list, and then use filter. Okay, then the name of the function, right? So this will be a function, and the name of the list, right? List name. This is a syntax, right? Now let's actually execute that. So we'll say odd nums equal to list filter, and then the function name. What's our function name? Find odd, right? Okay, and comma the name of the list, numbers. So this is the syntax. If we look at odd nums now, we will see the odd numbers. Now let's use lambda. So we will say here odd, I'm just going to call it odds, equal to list, and then filter. Now we're not using that function, we're going to specify the function here itself. So we'll say here lambda x, okay, colon, what do we want done with x? X %2 not equal to 0. Right, so filter x %2 is not equal to 0, comma, we need to specify the list numbers. Okay, and now if we look at odds, we will see we have the same result. Okay, so here we are actually defining the function using lambda. We just specify what we want done after the colon. Okay, moving on to the next question. Print squares of numbers from 1 to 10. Right, so how do we print squares of numbers? We could use list comprehension, but we're not going to do that. You know how to do list comprehension, right? You just say squares equal to x raised to 2 or x in numbers, and that's all, right? That's list comprehension. And then if you looked at squares, you would see the squares of those numbers. But of course we're using lambda. But to use lambda here, we'll use the map method. Squares equal to list and then map, okay, lambda x, and we need x raised to 2, right? Comma, what's the name of the list? Numbers, and that's all. And now if you look at S to S, you have the same squares. The next question says, in the cubes. That's simple enough. You can take the same expression that we use for squares, name this cubes, and then change this to 3, right? And then if we look at cubes, we will see the cubes of the numbers, right? Okay, moving on. Check if a string starts with a given letter. Now we know that Python has a method, start with, so we can use that. Okay, so here what we do is, let me just clear the screen again. Clear. So what we do here is we just say find character equal to lambda. We're going to get a string. What do we want done with that string? We need to say string1 dot starts with, and the character, of course, right? So this character needs to also come in as a parameter. So comma chr, right? And now we've accounted for using both chr and str1. Okay. So now if we pass to find char a string, let's say pineapple, comma p, right? So that would represent chr, and pineapple string1, and we say true. Yes, pineapples does start with p. But if we send E, we'll return false. Okay, so I hope you have a good idea of how Lambda works. Some more examples for you to practice on. Determine if a given string contains digits only. Now, I'm not sure I've mentioned this to you, but in any case, there's a function. So if we have a string, let's say s equal to 2, 3, 4, 5 in string format, if we say is digit, or rather s dot is digit, okay, we say true. However, if s was let's say a mix of letters and numbers, and then if we said s dot is digit, false. Okay, so we can use this now. How do we do that? Again, check digits equal to lambda. We're going to get in a string 1. What do we want to do with that string 1? Check if it is digits. All that we say is str1 dot is digit, right? And now if we pass in check digits with s, we get false. Change s to only digits, right, and send that back to the function. Check digits s, right? Moving on, find all months in the year that have a length of pi. For this we require to have a list. of the months. So we'll say months equal to January, February, March, April, May, June, July, August, as far as I'm going to go. So let's keep it up to September. Okay. Now we need to extract from here the months that have only 5 letters. How do we do that? So we can see here, find 5 equal to list, filter, and then we can say lambda x len of x equal to 5, comma, months. Right? And then if we look at find 5, you'll see March and April. The next one is print a list of multiples of 12 from a given list. So let's say we have something called multiply. No, this is another list. This will not do for this one. Let's create a list. Let's call it multiples of 12 equal to, we have 144, we have 35, we have 96, we have 78, we have 36, we have 24, and 100. Okay. Now what do we need from here? Only the multiples of 12. How do we do that using lambda? We can say find 12 equal to list, filter, lambda x, what do we want? X percentage 12 equal to 0, comma, what's the name of the list? Mult 12. And then we say find 12, and we have those. Okay, moving on. Determine if elements of a list are palindromes. So here we have a list. Okay, let me just clear the screen again. If you get stuck like that, just Control C and you'll come back, to the prompt, and then you can proceed. So now, as I said, we have this list, right? We need to extract the words that are palindromes. How do we do that? Again, we can say find palin equal to list, filter, and then lambda, right, x, and now we know how we check if x is a palindrome. What do we do? X starting at the beginning, going to the end, in reverse, right, should be equal to x, comma, list name. And then if we say find palin, we have all the palindromes. As the next one, multiply numbers in a list by a given number. How do we do that? So here we'll say we have that list now, multiply, right? So we want these multiplied by a number that we're going to send in. So we say here multiply by, so here we can say lambda, and we need the parameter. So let's say LST 1, and then for each of those elements we need to multiply it by a number. So which means we're going to be having another parameter coming in, right? And then we can say show it to us in list format, x into num or x in list 1, right? And now we say multiply by, and we send in the list multiply and the number 3, and there we have our result. Each of these elements is multiplied by 3. Okay, moving on. Find the list of maximum length in a nested list. So if we have nested, here we've got a list of lists, right? How do we find the maximum using lambda? Again, let's just say find max equal to lambda, and we're going to get in the parameter. So list 1, and what do we want to do with list 1? We just want the maximum of that. So max of list 1. And that's all. And then if we look at find max and we send in nested, right? And we get the list with the maximum number of elements, right? Next. Now these, I'll do this one, I'm going to leave these for you to do, right? The reverse and the convert strings to digits. Okay, so now sum up two lists. For this one, we have list 1, okay, equal to 1, 2, 3, and then we have list 2 equal to, let's say, 6, 7, 8. And now the result should be 1 plus 6, 2 plus 7, 3 plus 8. How do we do that? We will say here, find sum equal to lambda. We're getting two parameters, L1, L2. What do we want to do with those? We want L1 of counter, right, plus L2 of counter, right, or counter in range 3, or you can say length of L1, right? And that's all. So now we say find sum, and we send in list 1, list 2. You will get the sum. 1 plus 6 is 7, 2 plus 7, 9, 3 plus 8 is 11. Right? And as I said, these two, I leave them up to you. Right? If you have any problems doing them, you can always mention in the comments, and I'll get back to you as soon as I can. Now moving on, we need to discuss recursion. Before we get down to discussing recursion, remember we had written a function to find the factorial of a number. And this is a flow chart for that. We all know that the factorial of a number would be, I'm just going to put a comment in here, we would have factorial, let's say of 5 would be 5 into 4 into 3 into 2 into 1. Right, so how would we put this into code? And like I said, we've done this before, but just to refresh your memories, we have a variable fact equal to 1. This is a decision box. We check if the number that we want to find the factorial for is equal to 0. Remember, we are starting with the number 5. So the first time it's going to be equal to 5, which is not equal to 0. And then we have fact equal to fact multiplied by n, right? Which will give us the value 5. Then the next step says n should reduce by 1, which means n becomes 4. Control passes back to this point. We check if 4 is equal to 0, obviously not. We then have fact equal to fact, which currently has a value 5, multiplied by n, which is 4, right? Then we reduce n by 1 again, so n becomes 3. Control goes back here. We check if 3 is equal to 0. It's not. So we have fact equal to fact, that's 5 into 4, multiplied by n, which is 3. So 5 into 4 into 3. Right? Then n is reduced by 1 again, which means n becomes 2. Control goes back here. Is 2 equal to 0? No. So fact is equal to fact into 2. What is fact currently? 5 into 4 into 3. So we'll have 5 into 4 into 3 into 2. And then n is reduced by 1 again, which means it's 1. We go back and check. Is 1 equal to 0? No. And so we multiply whatever's in fact, which is 5 into 4 into 3 into 2 into 1. Then we reduced n by 1, which means n is now 0. Control goes back there. Is n equal to 0? Yes. And we print out or return the factorial. Now this is, as I said, without recursion. What happens with recursion? I'm going to write the code first. Okay, and then we'll see a visual of how it works. So let me clear the screen again. Now this is what I need. So now I've got these ellipses because I made a typing error there and it's not going to get you anywhere. Just press Ctrl and C. You will interrupt and then just type it in correctly. Right? So now for the factorial using recursion, let me just expand this. So let's see, def factorial, and we're going to be getting in a number here, right, as a parameter. Within this function, you check if num is equal to 1, right? We saw in that flowchart just now that if num is equal to 1, we checked for 0, of course, right? But in this case, we're going to check if it is equal to 1, return 1, else, now, with recursion, what we do is we call the function from within itself. So here we're going to say else return num into factorial and call that function reducing num by 1. Okay. Now let's try to execute this first. Factorial of 5. So you see we get the factorial there. So what actually is happening and how is it working? Let's take a look at the slide. So with the first function call, it's been called with 5, right? Our number is 5. Okay. This function call is put onto what is called a function called stack. Right. So now we've got the first sort of entry into that stack. Then the next time the function is called, remember n is reduced by 1. So the function is called with n equal to 4. Right? Remember our check is if number is equal to 1, return. So that's when the returns start. But when we are saying here return num into factorial of num minus 1, because we are calling this function again, right? That function call is recorded on the function call stack, right? And this will go on. So we'd have function call with n equal to 3, with n equal to 2, with n equal to 1. Notice how we move backwards, right? This is our stack, and each of these is a stack frame. So every time there's a function call, there's a stack frame, that is, and the technical word is pushed onto the stack, right? Now, when number equals to 1, that's when we start the return. So the moment the return starts, so we say if num equal to 1, return 1. So then what will happen is the value return will be 1, and this stack frame will be popped off the stack. Then there's a second return, right? And so the value return will be 1 multiplied by 2, which is 2. And of course, this is popped off the stack, right? That stack frame is gone, and so on. We have value return equal to 6, and that function call is popped off the stack. And then we have value return equal to 24, and the next function call is popped off the function call stack. And finally, we have value return equal to 120, and the last function call is popped off the function called stack. And the stack is nothing but a block of memory. Okay, so they're all memory addresses, right? And that's how recursion works. So now, what if I told you that I needed you to find the sum of all numbers up to or until a given number? What this means is if I give you 20, find the sum of all numbers from 1 to 20. How do we do that? Using recursion. We will say find sum, and of course we need that number, right? And here we'll say if num, now let's try with 0, right, equal to 0, return 1, right? Else return num plus, now we need to call that function again, right? Find sum with num minus 1. With recursion, we are always moving backwards. Why? Because remember, in the stack or the function called stack, when it's popped, it's always popped with the last stack frame being released first, right? So it's like a last in first out order. Okay, so that's it. Now let's say find sum, let's say with 10, or let's say with 5, Okay, so it should be 5 plus 4 plus 3 plus 2 plus 1, right? Is 5 plus 4 plus 3 plus 2 plus 1 16? No, right? It's 15. So what's happening here is, because we said if num is equal to 0, we are getting that extra function call, right? And an extra stack frame being placed on the stack. So if we change that, okay, I think we'll have to write this again. So let's just write that again. Find sum num, right? And then we'll say if num equals to 1, then return 1, else return num plus find sum with num minus 1, right? Now we say find sum with 5, we'll get 15. Similarly, if I ask you to find the product, right, up to a certain number, of all numbers up to a certain number, what would you do? Find the product of all numbers until a given number. You do the same thing, right? But here you would say find product with the number, of course. Then if num is equal to 1, then return 1, else return num multiplied by find prod with num minus 1, right? And then if we say find prod with 5 into 4, that should give us 120. Okay, now moving on, we need to do our first mini project, which is guess the number. Play against the computer. The instructions are the computer should generate a number randomly. Let's see how to do this. We need to use the module called random. So we'll import it and use a method from there. The user has 3 chances to guess the number. What is the logic we'll apply? The computer needs to generate that number. Then we'll have a counter that counts down from 3 within a while loop. Right? If the user guesses correctly, we break out of the loop and print a congratulations message. Right? And we ask the user if he or she wants to play another round. If the user does not guess correctly, of course, then the user still has 2 chances left after the first one is done. And of course, we in any case have to ask the user if he or she wants to play another round. So let's go now and write that code. We need to go to idle, and we have the main function. We have one more function which we will call pre. Now what do we put in this main function? Right, like I said, the computer has to generate the number. So for that, we need to import random, that's the module, and we also import sys. Why? Because we can use sys.exit to quit the program. Okay, now we have a while loop, which will be an internal loop. Within that loop, what do we say? Num equal to random int. Now this is the method we're using, randint. We've got to say actually random dot randint and the numbers that we want the random number from. So you got to specify the start number and the end number. This will generate any random integer between 10 and 20. Okay. I hope that is clear. Then we will call the play function. And after the play function, we will ask the user whether they want to continue playing. Reply equal to input another round, enter y for yes and n for no. Okay. And then we need to check the value. So if reply dot lower is equal to n, then we can just exit sys dot exit. Right? Else this will just go back right into the loop. So I hope that is clear. Now for this play function, what we need to write in the play function. So what do we write there? Within this, remember the user has 3 chances. So let's have a counter first equal to 3. And then we say while counter is greater than 0. And we are counting down. And then we say your guess equal to input. We need the user to enter the number. Guess the number I thought of. Right? You have 3 chances. Okay, let me just expand this. Right, so here we have our message. Then what do we do? Once the user enters something, what do we need to do? Remember that this is going to be in string format. Input the function always returns output in string format. So if we need to check this against the number that is randomly generated, then we need to convert it, right? So if int of your guess, right, is equal to num. Okay, so num now is basically generated within the main function. Is it available to play? No. So what do we need to do? We need to declare it as global, right? Global num. Okay. Right, so if int of your guess equal to num, then what do we do? Print well done. Okay. You win this round. And then you need to break out of the loop, right? Else, and let's see the indentation is right. Okay, this indentation is not right, so we're going to have problems then later on. Let's correct that now. And then And of course the if needs to be indented as well correctly. Now everything should be fine. Okay, so if, and then we break, else, what do? We reduce counter by 1, right? And we print you have, let's see the space there, plus, we can specify how many chances the user has left. How? By using counter. So str of counter, right, plus chances left. Now what happens when the user comes out of this while loop? Right, if we break from this, then what do we need to do? So here we need to ask, or check rather, if int of your guess is not equal to num, right, which means the user has exhausted his or her 3 chances and has not guessed that number. Then what do? We just print and that completes the message. So if your guess is not equal to none, sorry, better luck next time, and we show the number that was actually chosen. Okay, and irrespective of whether the guess is right or wrong, we still have to return. Return will take control to the line after the call to the play function, where we will ask the user whether he or she wants another round. Right, and that's all. So now I hope you've got this logic, right? We can run this now and see whether it works. So run, and the name of the function, the main one that is what is it called? Guess the number. So guess the number. Guess the number I thought of. Let's see, 11. We have 2 chances. 14. You have 1 chance. 10. Well, we didn't win. Let's see if this works now. Yes. Yes, the number I thought of. So that's working, right? We're going back into the loop. Let's say 15. Let's say 18. 14. We lost again. So let's say no, and this works fine, right? So that's the end of that first mini project. The second one is to do with a quiz. So this is our second project, and I've taken the liberty to put in the question and answer. As you can see, these are dictionaries, right, with their comma separated key value pairs. Now in this one, we're going to randomly generate a number which we will then use to access the question from the dictionary, pose the question to the user, check if the user answers correctly, and indicate that to him or her. If they don't answer correctly, then of course we're going to tell them what the correct answer is, and then ask them if they want to continue playing. Right? So let's write the code now for this one. The first thing we do is we will give the user some information. So after this, we will print some information about this game. So this is a trivia quiz. Okay, and then let's go. So just a message there. And after that, we will have a loop while true. Within that loop, we generate the number. Num equal to, we know how to do that now, random.randint, and it has to be between 1 and 10. Why? Because we have exactly 10 questions. Okay. Right, so now I have a question. Since a number is going to be generated randomly, there is a possibility that the number or the same question number appears twice, and we don't want that to happen, right? So what we can do then is we can take the question number and add it to a list, right? And then the next time you're asking the user a question, you can check that list to see whether that question has been asked already. Now, how do we do that? First of all, we'll say qnum equal to q plus str of num. What are we doing here? We are concatenating q with the number. So we'll get that particular key, right? So q1, q2, etc., etc. Then we'll check if qnum not in q list, which means now we need a list here, right? So here we'll say q list and we initialize it. Then what do we do? After we do that, if qnum not in qlist, which means a question has not been asked, right? Then we can append it. So qlist dot append qnum, and again, if it is not in the question list, we can then proceed to call the function play with that number, right? Okay, now let's go and write the play function, and this is going to bring in that parameter. We can name it the same or we can name it differently. I'm choosing to name it the same, right? And within this function, what do we write? We'll have answer equal to e plus str of, we just need number, right? So num. Now again, num is not available to this function, so we need to declare num as global here. Global num. When it's declared as global, then it's available to all functions, right? So once we've done that, we've got the key now. Then we'll say correct answer equal to answers, right? From there we want answer. Remember that it's a dictionary. That's why we are using this syntax to access it. Then what do we say? We can ask the user the question. So print questions using qnum, right? So q1, q2, etc. So we're using the key. Then we have to ask the user for their answer. Your answer equal to input your answer. Right? Then we got to check what the user has answered. Right? So if your answer equal to correct answer, so if it is a correct answer, right, then we say print well done. Right? Else, if it is not the correct answer, what do? Print wrong. The correct answer is comma correct answer. And of course, you can leave some space so that correct answer appears after a space. Right? Then what do? What we've done so far is we've kind of saved now into this variable the key for the answer. Right? We got the correct answer. We printing the question out. We're asking the user for their answer. If the answer is correct, print well done, otherwise wrong. What do we do after this? Ideally, we should be returning. So let's now see here. After this, return. Now when control goes back, where will it go? It will go to the line after play. But this is within an if. If unum is in the queue list, then what do we want to do? We want to generate a new number, right? So else continue. So this will make sure that if unum is in the question list, then we just go back and generate a new number. Right? After this, we need to break somewhere, right? So what do? We just specify within this loop reply equal to would you like to continue playing? Again type Y for yes and N for no. Right? And of course we need a response. So we'll say here input then we check if reply is equal to no, and we can say reply dot lower here. Then what do? Sys dot exit. Do we need an else? We don't, right? Because this is a while loop that is eternal. So if it is not equal to n, we'll just go back into the loop. Okay, and that's it. So let's now run this and see what happens. Run. Okay, end of line while scanning literal. So we have an extra code there. So we need to delete that. Okay, run. Invalid syntax. So why is that invalid syntax? Here we need to use double quotes. Right, or we need to use that escape character, one of the two. Run. Okay, I'm going to start in a new shell so that we don't have it so crowded. Trivia. Yes. Okay. Answers is not defined. This is coming from which function? We need to check that. In play. Now why is that? Again, because we're using answers here, but we haven't declared it as global. So let's declare answers as global. And we also need to declare then questions as global, right? Questions. Right, because within play we are also using questions. Run. Okay, let's start a new shell. This is a trivia quiz. I will ask you some questions. Let's see how many you get right. Scotland is a continent or a kingdom? It's a kingdom. Wrong. The correct answer is kingdom. I see what's happening here. This is because this is in uppercase. How do we take care of that? Let's kill this process. We need to make sure that whether the user enters lowercase or uppercase, that the answer is accepted. Right? So here what we do is we can say where we're checking for the answer, that is if your answer equal to correct answer or your answer dot upper, let's say the user enters everything in uppercase, equal to correct answer dot upper, right? Then print well done. Okay, let's try this out and see what happens. So run. Trivia quiz. Where in the world is the longest river located? Let's say Egypt. Now what do we have here? Correct answer is not defined. Okay, I think because I read correct answer, it should be ENS. Run again. And start in a new shell. Trivia quiz. First dollar coin made in which year? I don't know, maybe 1787. Wrong, 1794. Now why have I put this in words? I'll tell you later. Would you like to continue playing? Yes. How many times did Cristiano Ronaldo win the Ballon d'Or? 6 maybe? Wrong, correct answer is 5. Would you like to continue playing? Yes. The star actor in the Bond movie series. Let's see. I know that's Matt Damon. Okay, great. Right. Would you like to continue playing? Yes. Where would one find the Sea of Tranquility? Where? On the moon. So you see this is working. Right. What chess piece can move only diagonally? The bishop. Okay, we don't want to play. End. Now you can test this out, see if you find any bugs. Of course, do let me know if you find any bugs. Right. Now, the next thing I want to do is to just give you a sneak peek of what we're doing the next session. We're going to be doing text to speech. We're going to be using GTTS, which is Google's package, and then we use Python as well. Okay. I want to play for you something. I just wanted you to get a feel of what we're doing next time. So I'm just going to open that file. So here we are using the Python package. I will just run it now.
How are you?
I am fine, thank you. Are you back from work or working from home?
Working from home most days of the week. Oops. There's a call coming in. Gotta go now. Bye.
Right, so this is what we're going to do, just a taste of it. This actually ends our session for today. So in the next session, as I said, we do text to speech and speech recognition as well. Till then, take care, stay safe. Bye.